is actually going to take us probably 2 days. I think I know where I want to break in between, but if you look in the notes packet, it's like it's a lot of problems, but it's going to cover 2 separate days. So we kind of have like our intro level 1 equations, and then we'll pick up the pace a lot more next class. But the next 2 days are all about solving absolute value equations. If you can understand how to do it with an equation, the next thing we're going to do next week is just an inequality. There's a slight difference, but it's not too much. So we've got a couple more check for understandings, not next class, but the following class you'll have an equations one, and then following that you'll have an inequalities one. Remember, this test is coming up on the 2nd and 3rd. It's 3 different grades, so it's your last grades in here are going to be, or for this quarter, are going to come from transformations, which is like basically what you just did a little CFU on. It's kind of its own thing. Hopefully it's easy. And then the equations and inequalities are much more like beefed up algebra. And then those are going to be like separated again by topic as well, because they're similar but different. So it's going to be 3 different grades there. And then that will take us, it's not the end of the quarter. Oh, I put my birthday on there in case you wanted to mark your calendar. You don't have school, but I do. So you can send me a happy birthday email. But that's not the end of the quarter. There's still like 4 more days after that. But as far as like grading wise, this is where we are. And then just a reminder, if you still have retest to take, tomorrow is the final day. Unless you reach out and make arrangements, but you should have already done that because I've been telling you this for weeks. So that's what we got. So let's jump into, you will have Delta Math like starting today. I believe it's broken down and tells you like day 1 versus day 2. I'll check that. And if it's not, then I'll fix it. Because we're only going to kind of start, like I said, this is kind of our level 1 solving is going to be today, and then we're going to really take it up a notch, level 2. So first thing, we kind of already talked about this when we did transformations, but what is absolute value? Write a definition for yourself. All right, what did y'all say? What is absolute value? It's your distance from 0. Not a whole lot of writing that needs to be done, but it's your distance from the number 0. I'm going to add on a number line because that is kind of how we're going to start looking at it. And you can see there's some number lines here, but absolute value is a distance. Distance always has to be positive, and that's a big idea when we get to these equations. So it is a distance. That means that it always has to be positive. Always positive. And so when we look at absolute value equations, the first thing we have to do is even make sure that it is possible. I mean, am I going to be able to get an answer? And what I'm really looking at there is my absolute value equal to a positive number? Absolute value, we saw this with the graphs, but just so you're clear, absolute value equations are going to have these absolute value bars like that, okay? I need you to understand something about these absolute value bars that's very important. They are not at all the same thing as parentheses. This is an operation that you'll be performing on something. You're going to have like expressions in here. So there's going to be multiple things going on inside the bars. We're going to get to where there's stuff going on outside of those absolute value bars. Y'all, you have to think of those bars like jail, okay? You don't go in jail. You can't go out of jail. You cannot just take stuff in and out of these. That is a huge illegal math move. And so there is a way that we work around solving these, but like, do not go in jail, okay? Like in life and in absolute value equations, please, okay? So when you see these, you will see those absolute value bars. So our first one is, okay, here's our first equation. This is already solved. It's almost solved. Super easy. So absolute value of x is equal to 5. What values make that true? -5 and +5. Why are there 2? Because it's a distance. So here's 0. And if I'm looking for a distance being 0, I can go to the right side 5 units, which will land me right there. That's a distance of 5. But I could also go the other side to the left side. I'm still going 5 units, but I'm landing at 2 possible solutions. So when we talk about the absolute value of something, we have to consider both those sides of the number line, the left side and the right side. So how we can go solve these, kind of keep that in mind. There's two possibilities, two distances that would be that far from 0, okay? And go back to that picture if you need to. What about absolute value of x equals negative 5? Why? Because it's negative. Absolute value, distance will never be negative. Okay, you will not, there's no place on this number line that you're going to get a distance of negative 5. So this is not possible. No solution. No solution. There is not one. Okay? And the reason why is because absolute value cannot equal negative numbers. So I'm going to write that over here. And then I'm going to highlight absolute value of anything. It doesn't matter what's in here. It cannot equal a negative number. And I want you to make sure you know that because it's going to save you a lot of work if you get to a problem and you get absolute value equal to a negative number. It's easier. It's no solution. Stop. But you've got to recognize it. Distance will never be negative. We cannot do that. Okay? Graphically, since we kind of understand the way that the absolute value function works, because we transformed a whole lot of it, you can kind of see visually, we're just going to draw some examples, and then we're not really going to graph much anymore in this, but you can kind of visually see like how many solutions you could possibly get based off how those graphs intersected. So if you had, it's possible for you to have 2 points of intersection. So I'm going to draw just the parent function, absolute value. This is not very accurate because I'm just like, whatever. But I'm going to put those parent function graphs on each one of these. And then we're going to draw in lines that show the number of solutions above. Like that. And this is just for, like I said, a visual representation so you can understand why sometimes we get 2 solutions, sometimes we get 1, sometimes we get none. Okay? So I can have an absolute value graph intersecting with lines, horizontal lines, vertical lines, increasing lines, that they're going to have 2 points of intersection. So here's one right there. Okay? 2 points. My graphs cross here and here. You can do another one that even has like a slanted line. So if I have a graph that goes like this, it's crossing my absolute value graph 2 times. Okay? So those are 2 different graphs. You can kind of see what's going on. So it is possible in your algebra for you to get 2 solutions for x. X could be this or x could be that. That's pretty common that that's going to happen. Okay? There are cases where it only intersects like 1 time. An example of that would be like if you have, I don't know, like a vertical line that's intersecting your graph just 1 time. Or if it just touches like at that vertex point, that would be an intersection again at just 1 time. And then the last case would be that there's no solutions at all because there's no intersection point. So that would mean like your line is just happening below your graph. They're never going to cross, or just way off of your graph, and it's never going to cross that way. And so it is possible to get no solutions there. Okay, so these are kind of the possibilities that we'll get with our answers. Sometimes we'll have 2, probably more often than not we'll have 2. Sometimes we'll only have 1. Sometimes we will have none, okay? And we kind of talked about when that case is going to arise when we have absolute value equal to a negative number. That's kind of the easiest way to see it originally, but sometimes you really don't know until you check your answers. So checking your answers is huge in this unit, and going back in and plugging in your inputs to your original is going to be a really big deal, okay? So these equations are a little bit more involved. They're not like a system involved. There's not as many steps as that, but there are like quite a few here. So flip over, and I want you to just kind of read this little paragraph right here at the top, and then we're going to work an example together. But I want you to kind of read and think about what words I said on the other page. See if you can kind of interpret that here. example here. So there's kind of some steps. We're going to build on these steps. Again, we're starting like very basic, so that way you get a really good understanding of how it works, and then we'll just kind of add more and more layers each one. That was lucky you. My shirt. Okay. All right. So I don't even know where I was. This is a baby level 1 problem, level 0 problem, okay? How to get started with that. So here's the thing. What did I say about the bars? What are they? Say it back. They're jailed, okay? Where is X right now?
In jail.
X is in jail, so we can't just take him out. 5 is also in jail. We can't just take him out either. So here's our workaround when we need to move stuff out of the jail bars, okay? We are able to take this absolute value equation, technically step number 1, which we don't have to do in this problem, but we need to get the absolute value part of the equation all by itself. So that means if there's anything going on that side, like behind the bars or in front of the bars, we're going to have to move it. We'll get there. We're not there yet. But I am okay. I have my absolute value of whatever. And the next thing I want to check is it equal to a positive number? If you get your absolute value and it's equal to a negative, is that even possible at all? No. So you stop and you write no solution and you save yourself a lot of algebra. Okay? But this case, we are equal to a positive. Our absolute value bars are by themselves. It is just absolute value equals positive. I am okay to now start actually breaking this apart. And I'm literally going to break this equation apart. If you think about the absolute value graph, there's like 2 graphs. It's 1 graph, but there's like 2 branches with it. So it basically is like a little branch from a linear function and a linear function put together. So my workaround to get my variable by itself, to be able to move out of the bars, is to take the bars away and to think of this as 2 different equations, okay? And that's where we go back to the number line. There was 2 ways to get a distance of 5, going to -5 and going to +5. There's going to be 2 ways to get a distance of 7. What's the first one going to be? X plus 5 equals +7, and X plus 5 equals -7. So you need to recognize that you've got to consider both the positive and the negative. And then what happened to my absolute value bars when I separated it out? I don't have them anymore. I pulled this absolute value equation into 2 separate linear functions, but I'm considering both sides of the number line. This is like the left-hand side of the number line. This is the right-hand side of the number line. Well, now that there's no bars, I can move that 5 across the equal sign however I want to. Well, however you should do, following your mathematical operations. But now I'm just solving this linear equation and solving this linear equation. So what do I do with the +5? Not in the bars. Subtract it over. -5 here, -5 here. This gives me X equals 7 minus 5 is 2. For the left-hand side, I'm going to do the same step. -5 here, -5 here, but I'm subtracting 5 from a -7. -7 minus 5 is -12. Now, before you box your answers, I said it's really, really important to make sure that you always go back and check these, because you run the risk of getting extraneous solutions, which is the next little paragraph that we're going to read in a second. So you want to make sure that these guys actually work back in the original absolute value equation. It is tedious. It will get tedious the more advanced that these get. Sorry, is what it is. But it's very, very important because, again, there are times that you may algebraically get a solution to these separate linear equations, but it does not check back out in the original because we are changing the original to work it as 2 separate lines. That's just the process of doing it, okay? So when I check, I'm checking in this original absolute value equation. And we've got 2 solutions to check. So here I go. Absolute value of, well, my first one was X is 2. 2 plus 5. Is that equal to 7? Question mark. 2 plus 5 is 7. The absolute value of 7, is that 7? So X equals 2 is a legitimate solution. Yeah. Now I want to check absolute value of this solution, -12 plus 5. Is that equal to +7? That's the question. No. Okay? What is -12 plus 5? -7. But in the original, you're taking the absolute value of -7. Is the absolute value of negative 7 equal to positive 7? Yes. So this is a legitimate solution. The problem is not having negatives in the absolute value bars. The problem is when the absolute value is equal to a negative. So yes, this is still true. This still does work out. Both these guys win. Okay?
Can you say that again?
Which part?
The last part.
The problem? So your problem lies when it's okay to have an absolute value of a negative number. You can take the absolute value of a negative number. You cannot have the absolute value equal to a negative number. Okay? You'll see it. You'll see it. But that's the problem is when it's absolute value and the guy that's not in the bars when he's negative.
Okay, so how is negative 12 plus 5 equal to 7?
It's negative 12 plus 5 because this is negative and this is positive.
I see.
You're just doing it, but then you're taking the absolute value of that. Okay? Yeah, because negative 12 was in our solution. So that's your first one. Again, very basic, very intro. So next little paragraph here has to do with extraneous solutions. Have y'all seen anything that has extraneous solutions yet in math? Have you seen that word before?
Nope.
Okay, I kind of always harp on it as extra. Okay? They're basically solutions that could algebraically, whenever you manipulate an equation, like when I split this into two linear equations, or when I you'll see it again when we square both sides. When you just perform a mathematical operation that maybe is totally fine to do, but sometimes it can give you these solutions that you get, but they don't check back out in the original. So there's several times this year that I'm going to be we have to check for extraneous because just in our steps, they could just pop up. And sometimes we have to throw them out. So I've kind of already said that you have to check your solutions to make sure you want to plug back in. We already did that, okay? So remember our steps. Isolate our absolute value. Did we isolate our absolute value on number 2? Is the absolute value bar is all by itself. Nothing in front of it, nothing behind it. Okay, it's absolute value, blah, 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 equals 13. This guy's positive. Are we good to go? Is this even possible in life? Yes, it is, because 13 is positive. Okay, now we're going to be able to work around the bars, and we're going to split this into two linear equations. 2x minus 5 equals, I always keep the positive one first, but then the other equation I'm going to look at, 2x minus 5 equals negative 13, okay? This is the left side of the number line. This is the right side. Do y'all know what I mean when I label those? On your number line, you've got negative 13 is over here, and that's 13 units, and over here. Okay, solve those. 13 plus 5 is? Divided by 2 is 9. Over here, negative 13 plus 5 divided by 2, negative 4. Again, I got two solutions in my algebra, but I have to make sure that they actually work. When you check, you got to go back to the original absolute value equation. So check AV equation. Absolute value equation. Okay? Is absolute value of 2 times 9 minus 5 equal to positive 13. Okay? 2 times 9, 18. 18 minus 5, 13. The absolute value of 13 is 13. Check. I'm going to put a question mark there. So 9 is a valid solution. Okay? Negative 4. Absolute value of 2 times negative 4 minus 5. Is that equal to 13? 2 times negative 4 is? Negative 8 minus 5 is? Is the absolute value of negative 13 13? So this solution is also valid. Okay? So there's two solutions in this. We didn't get an extraneous there. We're going to get one. I don't know when. But we will at some point. Yes? like number line, the right side of the number line, the left side. Some people like that. I don't know. I don't always do that, but it's kind of like here. This will be the right side. This will be the left side. Just both solutions to consider. I don't know if I'll keep doing it because I normally don't. But these both do work. This is totally like fine for tests, CFUs, writing like x equals x equals. Delta math, how I think Delta math is going to have you do it is a set. So let me just show you that so that way you're not confused. They just have you type, like if you get these two numbers, you will just type like 9, comma, -4. And I think Delta math will do like a set like that. So it's just like these are the possible x's. You don't have to type like x equals x equals. So you could kind of list it like that, Delta math-wise. Okay? All right. I don't think you're going to, well, that's a lie. Try 3 and 4 on your own. Ready, set, go. Number 3 real quick. Okay? Because remember what I just say. Fractions are our friends. Okay? We're not scared of them. So I went ahead. This was already set up. We had the absolute value bars all by themselves on the left. I typically prefer them to be on the left. If they are not, I will move them. Okay? So absolute value on the left, positive number on the right. I'm good to go. I do my split. I drop the absolute value bars. And I just make the left side of the number line, right side of the number line, one positive, one negative, and then I solve from there. And I get 2 possible solutions. Does the 2 check out? Yes. I'm going to walk you through the checking just in case you're struggling with that. So this will be 7 times 2 minus 10. 7 times 2 is 14. 14 minus 10 is, why did I write 14 right there? I don't know. Is the absolute value of 4 equal to 4? Yes, okay? Don't be afraid of the fractions. You got it. Plug it into the formula. 7 times 6 over 7. You're welcome. This isn't very terrible. What is 7 times 6 over 7? 6. Those will simplify out. 7 over 7 simplifies to 1. There's a 6 left up top. 6 minus 10 is -4. I don't know why I keep writing the wrong number over there. The absolute value of -4, is that equal to +4? So this is possible. Okay? Both of those solutions work here. What happened on number 4?
It's no solution.
Why?
Because there's a negative.
Because there's a negative. Who actually did the algebra? Did you check it?
What do you mean?
Did you do the algebra with it?
And I got stuck and I was like, oh, it's because I can't do it.
Okay, so I was going to show you. This is no solution. Why is it no solution? Absolute value cannot equal a negative number. That is why. But your answer is no solution. Okay? On Delta Math, if you get one of those, in your answer blanks, I'll try to remember to show you, but it's like the answer blank where you would type, and then to the side, there's like a little plus and a minus, and if you hit the minus, it will give you like an empty set here. But just in case you did, I worked this out at a different time to show you that algebraically, this is an old answer key, but it's the same problem. Algebraically, if you don't recognize, I want you to get to where you're like absolute value, negative number, no can do, save yourself the time. But if you were just being silly and you just breeze through it, you would get actual like answers. But when you go check them out, and this is what I was talking about here, Joshua, when I plugged this answer, this is the same problem that we just did. I just don't have space to write it on my packet. Apparently I had more space last year. When I went back to check, so if I got x equals 3 and I plugged 3 into the original right here, this gave me the absolute value of -7 is equal to what kind of 7? That is where the problem is. The absolute value of -7 is +7. +7 ain't the same thing as -7. So it's better for you to catch it early on, right there, and I think most of y'all did, but it is possible at the end if you just, like I said, made it oopsies and saw it there. But I want you to recognize it earlier because it's just way easier, okay? All right, we okay with like level 1 problems? All right, level 2. Extra step. You must isolate the absolute value part of the equation before you do your split. So I've kind of been prompting you on this. I've been talking about, is there anything before it? Is there anything after it? So let's look at what we got. 5 times the absolute value of x plus 4 minus 2 equals 43. What are we not gonna do?
Change the jail.
We are not going to distribute because what is absolute value? Jail. Can't go to jail. Do not be tempted. I promise you, there will be someone and public shame. Okay? No, we don't do that. Okay? We have to isolate that. We have to get those bars completely by itself. Okay, I want to show you. I'm going to try something new. I've never taught it. Well, I've taught this later, but I want to try today so that way when you see it tomorrow, it'll be a little bit easier. Hang with me for a second. Okay? I'm going to let someone pick a letter.
B.
B, not X. We don't want to use X. I'm going to let B equal absolute value of X plus 4. Just hang with me. I promise I think this is going to help with some type of problem that we're going to do next class. So just for a second, I'm going to let B be equal to the absolute value of X plus 4. That was just in the problem like that. Okay? We okay? So let's rewrite it. 5, instead of writing absolute value X plus 4, what can I put instead? B minus 2 equals 43. I'm hoping that if we kind of approach it this way, maybe that will keep people from distributing into jail because it just seriously annoys me so much. It's not allowed. Okay, so let's isolate B. Algebra 1 days. How do you get B by itself? Add the 2. So this will give me 5B equals 45. Okay, divide by 5. B equals 9. Okay, now let's take B back out of it. What is B? Absolute value of X plus 4 equals 9. Okay, so do y'all see what I did? Just kind of like, and I promise this is going to help when you see some problems that are like real crazy looking. I just kind of took that absolute value out for a second. I wanted to set it up to get my absolute value bars all by itself. Okay? Do you have to do the B thing? No. But if it helps you not to make the mistake of distributing in there, then by all means. Okay? All right, here we go. Now I'm looking here. Absolute value of X plus 4 equals 9. Positive 9. Are we in business?
Yes.
Yes, we are, because that guy's positive. So now I can do my split. And what are my two separate equations going to be?
X plus 4 equals 9 or
X plus 4 equals 9. X
X plus 4.
plus 4 equals negative 9. And this is quick to solve. Subtract the 4, X equals.
5.
Subtract the 4, X equals
Negative
-13. All right, am I going to circle them and move on? No, I got to do my check. Now, how do I want to do this? I want you to check in the original equation, the very original, like the one in ink, in case you've made some mistakes here, okay? So let's check the original. It's a little bit tedious, but that's okay. So let's check X equals 5. So 5 times the absolute value of, we're putting in our input of 5 plus 4, close your absolute value bars, minus 2, and then we're going to check and see, is that equal to 43? That is the question, okay? As far as this goes, work this operation first. 5 times the absolute value of 5 minus 4. 5 plus 4. What's 5 plus 4? 9. Okay, so this is 5 times the absolute value of 9 minus 2. Again, we're still questioning, is that equal to 43? What is the absolute value of 9? 9. That is the number 9. So now I can think of it as 5 times 9 minus 2. What's 5 times 9? 45 minus 2, is that 43? Yes. So this solution does work. Why is it safe for me to go from this step to this step? I went from parentheses to absolute value bars. I took the absolute value of 9, and that was the number 9. So that one is okay to, after you take it, then you can do your multiplication from there. Okay? Check 13. Negative 13, sorry. What is the absolute value of negative 9? 9. So it becomes back to kind of that original 5 times 9 minus 2. Oh my gosh, my brain is not working today. And that is 43. So this solution also does work. Honestly, I'm wondering if we're even going to see many other extraneous. It might not be till next class that we really start seeing extraneous. Yeah, looks like it. Except for the one that was like set equal to a negative already. Okay? All right, try 6.
6 is my ugly right now.
Oh. This is going to be ugly, isn't it?
Yeah, it is ugly.
Okay, good. We like ugly sometimes. Okay, so I'm going to do my little B substitution thing here. Although this one's pretty easily isolated. All right, we are gonna tackle this one. It's gonna be great. Okay, so to isolate, first step. Again, I did my little substitution thing. If you don't like it, then that's fine. You just have to know how to do it right. Okay, how do I get the 2 away from B? 44 divided by 2 is 22, and then I'm gonna put my absolute value bars back in. So here's what I'm really looking at: 2 over 3x plus 4, absolute value of that. I'm like really concerned about my brain right now. This is like the 5th time I made a number mistake. Thank you.
Would that change everything that you did?
60 does not equal 40.
No, it only changes how I just miscopied that down. But you still have to divide by the outside too.
Okay.
All right, y'all gotta watch me
This is
because I
mine.
don't know what's going on today. Actually, I think I do.
Then what do
Okay,
this one?
what are we? What are we gonna have to add? All right, let's just handle it. We got it. We can work together. Okay, so here we go. Are we good? Did I get the problem copied down right? All right, let's do a split. So here we go. 4 over 3x plus 4 equals positive 22. The other one is 4 over 3x plus 4 equals negative 22. Okay? Let's do the positive 22 one first. First step. What's the first step here? Subtract 4. Okay? So I have 4 over 3x equals 22 minus 4 is 18. All right. What do I do with the 4 over 3?
Multiply both sides by 3 times.
Multiply both sides by the reciprocal, which is 3 over 4. So I multiply 3 over 4 over here and 3 over 4 over here. And that's going to knock that out and leave me with x equals, okay. Any reducing? We can do some reducing early on. 18 and 4, what are they both divisible by? 2. 9 over 2. Y'all with me? Okay, 9 times 3 is 27. 1 times 2 is 2. 27 over 2. I prefer
54.
fractions, but you got what? Oh, yeah, that just reduces.
Because it's just easier to cross.
That's fine. Multiplying across is fine. I like to simplify before if I can. But do reduce at the very end. Because 54 divided by 4 is 27 halves. Okay, this one over here. Negative 22 minus 4. What's that? Negative 26. Same idea. What are you going to multiply both sides by? 3/4. And I like to write this as like negative 26 over 1, just so that way I can kind of see. Negative 26. Because you have to subtract the 4. That has to be done like very first thing. Okay, I like to reduce early because that's just how my brain works. But you don't have to. Negative 26 and 4, those are both even. So are they both divisible by 2? And this is negative 13. So negative 13 times 3 is negative 39 over 2. All right. Who wants to check it? We can do it. I don't want you to like freak out if you get solutions that are fractions, because it's like very likely that that could happen. Hint, hint, is probably going to happen. And we're not going to freak out. Practice checking this. Okay? So I'm breaking this into, we're going to keep going, and I'm going to keep checking this. The other one works, doesn't it? Negative 39 over 2.
I think she checks.
And I'm going to, but for time purposes, I'm going to go back. Someone else is going to check, but I'll put it in the answer key afterwards. But I just want you to hear me out today. Other than the one problem that we had, like absolute value equals negative, that would be a no solution problem. The rest of the time today, you should be getting 2 solutions that both work. I promise you, next class, we are going to see some that have answers that algebraically you find, but they are extraneous. Because just listen to me. Here's how we're breaking this into 2 days. Everything today is isolate your absolute value, and it's equal to just a number, just like one number. Okay. Next class, when we isolate our absolute value, we're equal to something with an x on the other side. So this is like an actual like linear function. And those are more of your cases where you might get one that works and one that doesn't. So it's a build-up, so I kind of need y'all to trust me. We do have to check. It is something that you have to be, like, intentional about, although it is annoying, but it is really important because when we kind of finish all of this, it will make sense. All right, flip to 9. Flip to 7. Flip to 7. Yeah. Okay, this one's quick. It is quick, I promise. Okay, look at me real quick. Don't let this mess you up. Okay, 9 minus 2. Are we allowed? Listen, star. Are we allowed to subtract 9 minus 2 when the 2 is attached to absolute value? No. Okay, if you do your little b thing, b equals absolute value of 2x minus 1. 9 minus 2b equals 16. I think this makes this way more visible at what has to move first. You're solving for b, Algebra 1 style. What do you have to move? You have to subtract the 9. You have to subtract the 9. And then you move away the negative 2. So 16 minus 9 is? What? 16. 7, okay? And then now you deal with the negative 2. Y'all,
Negative.
don't be that person that does this illegal math, okay? Move the constant, then divide by what's in front. And so we get b equals negative 7 over 2. Oh, it's a negative. Ding, 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 ding. What do you really have going on here when you put b back in? Absolute value of 2x minus 1 equal to negative 7 over 2. Is this possible? No. So what is your answer? No solution. Why? Because absolute value cannot equal a negative. Y'all, like bells need to be going off in your head when you have a negative number. Yeah.
The one reason you can't do it is because it's only with negative 2. So how many times do you think about?
Oh, people say 9, they say 7b. And you can't do that because 2 is being multiplied. 9 is not. All right, look at 8. 8 looks scary. 8 looks scary. We're not scared. We're not scared. Okay? First thing, I like my absolute value bars to be on the left, just personal preference here. So here's what I'm going to do. I'm just going to rewrite 3 times 4 minus 8. There's multiple approaches that you can take to solving this, but if you want to save yourself a lot of yucky fractions, you probably should do it my way. which is as such. Do we need to isolate our absolute value bars at all? No. Okay, it's crazy in there, but it's okay. It's by itself, and it's equal to a positive number, right? So there is possibilities to get solutions. All right, split. 3 times 4 minus a. Star this question. Do what? I wouldn't do that here because you don't have to get it by yourself. All over 2 equals 8. And then the other side is 3 times this. Actually, it looks way worse than it is, I promise. Equals negative 8. I would just break this down. Okay? I've split it. Drop the absolute values. I got positive 8, negative 8 here. The first thing I would do, get rid of that divide by 2 because it's ugly. How do we undo divide by 2? Multiply both sides by 2. Multiply here, multiply here. And so this will give me 3 times 4 minus a is equal to 8 times 2 is 16. Okay? Here's where you can continue to go somewhere else. Here are your 2 options. You can distribute 3n and then solve for a. You could divide by 3, but is 16 divisible by 3? No. So I would opt not to do that. If it was like an 8 or something and it does divide evenly, I would probably opt to do that. But for this, I would distribute in here and then solve it. So this would be 12 minus 3a equals 16, just to avoid fractions. I mean, fractions are our friends, but if we can't avoid them, probably should. So then now, what do we do here to solve? First thing that has to go is the minus 12. And then we divide by... You should get the same answer even if you divided. Because we're just mean and we want you to get fractions.
When a equals a fraction, it's
Yeah, I get that. We
28 cannot break the 3, right?
No. I want you to familiarize yourself though. Like, I'd rather you get a bunch of fractions today than get on the test and be like, panic mode, this can't be right. Because it's very likely that you're going to be getting fractions occasionally. Okay? And sometimes they aren't very pretty. No.
You got A is negative.
I'm not.
Okay. I think they both work. I will check them. I will put my checking on my answer key that goes on Canvas, but I want to give y'all a little bit of time to work on Delta Math. Let me show you what I need to make sure. I need to make sure that I. Here's your Delta Math that opened today. This is only over 3.2 and 3.3, but remember we split 3.2 into 2 separate days. So you're only going to work on, looks like there's 4 problems here. These are the random ones that they will like give you like over and over and over type of questions. You do have to isolate. Oh, this is what I was going to talk about. If you get solutions like 1, 2, and I didn't hit comma. 1, and then you would put the other one, whatever you get there. If you get a no solution, this little minus button, oh, that's nice that it has that button there. And so that's a no solution one. And then you've got 4 of those. And then this one is like a standalone problem. Ah, look familiar? There you go. Okay, those are the only ones. It's just 5. I'm going to ask you not to work ahead. If you are a working ahead person, please don't. Because we have more exciting things to do next class that I want to make sure I teach to you because this is my job. Okay? That's what we're working on.